All right, so 4-5, we are going to build on what we did in 4-4. But we're going to start by just using our graphing calculator to kind of envision what these graphs look like and what happens when I change the exponents. Okay? So go ahead on your graphing calculator and go to y equals. Have your graphing calculator. You can use Desmos. We're going to just do x plus 4 to start. Just do x plus 4, okay? And then when you hit graph, if you need to fix your window, zoom 6 is what fixes the window. Now tell me, where's the x-intercept? At -4, because if we have, I didn't have just x plus 4 written here, but if we have x plus 4 to the first, that is our only factor. So if y equals 0, we solve this for x, x would equal -4. So now what I'm going to do is I'm going to go back to y equals, and I'm going to write parenthesis x plus 4, close parenthesis, and I'm going to square it. I'm going to hit graph again. So this time we're doing squared. And you're going to tell me, where is the x-intercept? -4, because we still have our factors as -4. Oops, I didn't put a negative. However, the different pictures, let me put in the, you don't have to put in the original one, you can just look at mine. When I had that line, and when I had the parabola, the behavior at -4 is different. The behavior at -4. So the red one passes through the red one passes through -4. The blue one touches -4 and goes back up. Okay, so the behavior at -4 is different. If you look really, really close to -4, which you don't have to do, you can just look at mine, I'll do it. So I don't want to answer a million questions right now. Oops, I didn't do that right. So if I look really close to -4, if I look at the red line, at -4, it's a line. It's linear. If I look at the blue, at -4, it's a parabola. Okay, so now we're going to go and change it to cubic. So all I'm going to do is just go up to that power. I'm not going to retype it all. Go up to that power and change it to 3. Okay, so what is happening at -4? So at -4 is still the x-intercept, but what's happening at -4? It passes through it, but it has a funny shape. Do you know what kind of shape this is? It's a cubic shape. So at -4, because there's 3 -4s, at -4 it looks like a cubic function because there's 3 -4s. So what do you think could possibly happen if I type in x plus 4 to the 4th? What will my x-intercept be? Okay, but the behavior at -4. Let's find out. Well, 4 is even. It comes down and it goes back up. So it's the same behavior at the intercept as it was that we learned for the end behavior. So we didn't learn that just for one thing. We learned it for multiple things. This is called, on the paper, when we have different amounts of the exact same x-intercept, we're saying that it has a multiplicity. The intercept has a multiplicity. Has a multiplicity. And the multiplicity would be, for this last one, the multiplicity would be 4. It happens 4 times. The very first one, x plus 1, I wouldn't say, or x plus 4, sorry, I wouldn't say there's a multiplicity because there's only one of them. The second one, x plus 4 squared, has a multiplicity of 2. Yes, Avni? What? Well, we have 3 more.
No, what is it? What is the multiplicity?
That means there's 2 x negative 4. It's not always the degree. It was with this one. It doesn't always. It's just telling you how many x-intercepts there are. How many x-intercepts? Remember when we have a quadratic and you factor the quadratic? So if I have x squared minus 6x plus 9, and you factor that, and you get x minus 3 squared equals 0, and then you have to solve, and you only get one answer. Why did we only get one answer even though I'm supposed to have 2 answers here? Because it has a multiplicity of 2. It's the same thing twice. Well, this x plus 4 to the 4th power is a negative 4, another negative 4, and another negative 4. It has a multiplicity of 4. Like there are 4 answers, but they're all the exact same answer. Okay? So now we're going to try it different. This one has more than one x-intercept, so it's going to look a little different. So I'll type in x parenthesis x plus 5, minus 5. Yep. I caught it. And do you know before you graph it, do you know what degree this problem has? What degree it has? So this is going to be a line? Because if I multiplied them together, I would get x squared. So this should be a parabola. And where are the x-intercepts? 0 and 5. So all of my x-intercepts will be at 0 and 5. Now, this was a little bit different than the other one because I have 2 x-intercepts. My next question, I'm going to change x minus 5 to be x minus 5 squared. Okay? So now it should be a power of 3. Okay. So it passes through x equals 0. Why does it bounce off 5? How many 5s are there? It has a multiplicity of 2. So the behavior at x minus 5 is like a parabola. So I'm just looking at x minus 5 squared by itself. Individually, it's a parabola. However, the whole function is a cubic. Okay? Let's look at the next one. This takes practice for it to sink in. Bless you. So what is the degree? Before I graph this, the degree is going to be 4. So it's going to have an end behavior of both ends going up at the end of it. Here, if I change my window, it'll be a little bit easier to see. Let me, and you guys don't have to change your window due to time, but I'll change it just to make it a little bit easier for you to see it. It didn't help that much, but it helped a little bit. So there is one intercept at x equals 0, and at x equals 0, it passes through it just like it's a line. What is wrong?
No, nothing.
Okay. So it passes through x equals 0 just like it's a line because there's one of them. And then x minus 5 cubed, the shape at the 5 is a cubic shape. So the number of those same x-intercepts affects what it does right at the x-intercept. I'm going to take this one again, and let's put a different power on the x. Let's insert at the wall. You guys know how to insert? Do second delete, which is right here. It's an INS. I just put it in the wrong spot, I think. And then we can hit like square. Nope, I did put it in the wrong spot. I know. Second, insert, squared. Okay, and if you didn't get the delete or the insert, you could just retype it. But before I graph it, I now have 2 x's at x equals 0, and I have 3 x's at x equals 5. So this should be a 5 total degree, which means it's going to start down and go up. However, I don't know how stretched out it is. You guys want me to put something in front so it's not so stretched out? Is it stretched out bad? Or you haven't hit zoom? Or you haven't hit? I can always change it if we can't really see it very well. I mean, it's not too bad. I'll change my window. I think the window will help a little bit. -1 to... There you go. I changed my window a little bit. So you can't see the whole graph right now. But the most important part that I can see is what is happening when I changed it to x squared. What happened at the x equals 0? There's 2 of them, so what does it look like at x equals 0? It looks like a parabola. It's connected to the rest of it, right? And then there's 3 at x minus 5, so what does it look like at x minus 5? Cubic. So I don't know if you know why this one is a parabola that way. Was anybody wondering why this one is a parabola this way? Were you wondering that? Was anybody else wondering why it's a parabola facing down? Yeah. Okay. So if I do... This is cubic. What is the end behavior of this if the degree is 5? It's odd, so it's going to be like here and here. Now it has to hit x equals 0 twice. And it has to hit x equals 5 3 times. So in order to get this to do that and to pass through that twice and end up going down, I'm sorry, like bump off of, like, not actually pass through it, but go up and touch it and come back to it. In order to make it look like a parabola, because it has to go up over here and it has to be down over here, this has to be an upside down parabola.
So it's a double parabola with cubic.
Yeah, they're connected somehow. You're talking about like there's one here and one here? Yeah, but the one that we are learning about, we're not going to worry about this at all.
Oh, okay.
The one we're learning about is just our x-intercepts. Okay? This will be for a higher level class. Okay? Somebody poke him awake. Okay. It's hard to tell when your eyes aren't open. Your head's down. Okay. So it says summarize about the x-intercepts when they are repeated solutions. So if it's squared, what would the x-intercept be? If it's squared, well, it could be this way, or it could be that way. But if it's squared, there will be a parabola at that x-intercept. Let's say at. If it is x to the first, what does it look like at the x-intercept? It looks like a line, but it also could be going the other way line. So it's x to the first, it looks like a line at that x-intercept. But what if we have like a cubic amount of x factors, the same factors? Then at that x-intercept, it's going to look like a cubic, or could be this way. But that's the behavior that happens at the x-intercept when we have multiple of them. So we're going to solve example 1 by factoring. We're going to solve it by factoring. Then we're going to look and see it on the calculator. So what do I do first? GCF. Whew, I just did this one at the top of the page and I didn't even realize it. So then from here, I'm going to factor the trinomial, and you guys are so good at factoring that I'm going to do it really fast. And it ends up being x minus 3 squared. And we have it factored all the way. So if we were going to sketch this, if we were going to just draw a rough sketch, what would the end behavior be for a cubic, the end behavior, the stuff that we've already talked about for a while, and a positive leading coefficient? Odd, positive. What would it be? Different directions and going uphill. So I know my end behavior is going to be like this. I also know where are my x-intercepts. X equals this one. Oh, okay, 2x equals 0, so x equals 0. And I have x minus 3 equals 0. It's twice, right? But x equals 3. So I know I'm going to have an x-intercept at 0. I know I'm going to have an x-intercept at 3. But what's the behavior at these x-intercepts? How many x-intercepts are at 0? 1. So it's going to pass through. But it has to go down at the end. What's going to happen at 3? So if it has 2, what shape is going to be here? Parabola. And it's got to be the kind that opens up so that this will connect. That was what we already learned about, like the leading number is positive 2. I'm not doing bathroom right now. And then the cubic tells me odd. So it's the stuff we already took our quiz on.
So you know it's upward when like you already know where it's going down.
Like that's just using our end behavior that we've already learned, but now we're combining that with multiplicity at the x-intercepts.
Okay.
So I just sketched this graph and I haven't even looked at it on my calculator. Okay? And then we can check it on the calculator. If you guys want, I'll just do it real fast so we can go faster. Or you can do it as well. But 2x, I'm not even that fast. Cube. Oop. When I, on the graph? Yes. Yes. Oop, I forgot to change my window. That's okay. I don't need to change my window. You can kind of see it. Oops, you can't see it. It's not on the screen. But you can kind of see it. I didn't change my window back, but you can see it passes through like a line, and then it bounces off like a parabola. It has that shape, and we did that without even, yeah. Okay?
Bless you.
So these would be similar, but so is example 2. So I'm going to go to example 2 now. Because we sketched the first one. It didn't say to sketch it. We already sketched it because I knew we were going to do it anyway. So I'm just jumping to number 2 that actually says to sketch it. We're going to do the same thing. We're going to factor it first. All right, so I look at this. What should I do first for factoring? Oh, I'm sorry. It says find the zeros. What should I do when I'm finding the zeros? If it's an emergency, go. I'm sorry. If it says zeros, you have to make that 0 first, right? There's my 0. Okay. Then we can solve by factoring. So what do I do to factor this guy? No. What do I do to factor it? GCF. What are we taking out? I'm taking out a negative 2. I don't know about you guys, but I'm going to take that negative out. Yeah. So I got negative 2, x to the 4th, minus 8x squared, plus 16. Okay. I still have to factor this trinomial. Now this was an extra credit on 2 quizzes. Some people got it, a lot of people got it by just looking at the graph, but now we're doing it for real. So you're gonna, and we did one of these yesterday too, you're gonna look at this, instead of x squared, it's now x to the 4th. The middle term is x squared. That just tells you to make these both x squareds. The middle term tells you how many x's there are going to be here and here. So what can I put in these spots? Oh, minus minus. What's going to make 16? 4 and 4. And we check it, and it does work. But we are factoring this. Does x squared minus 4 factor further? Do you have a question, Avneet? Okay. Do you have a question, Kate? Does x squared minus 4 factor further?
Yes.
What kind of factoring is x squared minus 4?
There's a word for it.
Yep, there's 2 words for it, 3 words for it. Difference
Of squares.
of squares, right. Okay, so I factored that one. How about x squared minus 4? Oh, okay. So that's going to be x plus 2 and x minus 2 as well. So do I have all linear factors here? Like, are they all x to the firsts?
Yes.
Okay. So now I'm done factoring it, except I am going to combine the ones that are the same. So negative 2 times x plus 2 to the second times x minus 2 to the second. So we're going to solve this for x. So I first do negative 2 equals 0, but does negative 2 equal 0? Can I solve for x? So we don't need that. Don't need that. How about x plus 2 equals 0?
Yes.
Okay, negative 2 twice, right? And how about x minus 2 equals 0? Twice. So our degree is 4, and our leading coefficient is negative. So what is the end behavior? It is negative, and it is even. So it's just like a parabola that is negative, only it's not a parabola. Evens are just like parabolas. So the ends are going to be facing down. That's what even and negative does. We also have x-intercepts at negative 2 and at positive 2. But how many are there? So they're going to be parabolas. Now, we have to keep in mind it's going to be facing down when we draw this. So for it to be facing down and look like a parabola here at negative 2, it's going to look like an upside down parabola. And then it has to like go back up again so it can look like another parabola at positive 2. That's the only way it's going to have ends that go down. It's going to have to look like 2 little upside down parabolas. And then there's one in the middle, but we're not worried about this guy. We're just worried about the x-intercepts. Yep. More from this. Using calculator question. We may have to review this more next time I see you, but I'm going to do one more. You're going to go ahead and I do want you to do this with me. Type in not when you're graphing it. But what we're, if you look ahead, step 2 says use synthetic division, so yes, but not what we're graphing at. Okay, so I typed it in, I'm going to hit graph. And you will see we have how many x-intercepts?
3.
We have 3. You are going to be allowed to use your calculator for one of those 3. I usually choose the left one, but it does not matter. If the left one was one that I looked at and I was like, I don't know what that answer is, I might choose a different one. But do you think you maybe know which one this is? Okay, we have a way to check it, with a few ways to check it. If we do second trace value and we type in -1 for x, if it's a 0, it'll say y is 0. So is that an x-intercept? Is that a 0? Yes. So we have one of them. X equals -1. So we're going to pick one x-intercept. I'm going to choose x equals -1. Now what you get to do is we're going to do what you were just doing at the beginning of class. You're going to take out this x-intercept using synthetic division. -1, we're going to take out of 1, -8, 11, 20. Synthetic division. If you do something wrong, the remainder will not be 0. So the remainder has to be 0 for this to work. Once you get it down to a quadratic, oh, by the way, this is, write the x-intercept as a factor. We need to do that still. Once you get down to a quadratic is the next thing. So let's write the x-intercept as a factor as well. So if I have x equals -1, I have to add that 1. I already showed you how to do this, right? So my factor would be x plus 1. So that is my first factor. Don't forget about it. We have to find the rest of the factors. I'm only making you do 2 factors by yourself. So if we start with a cubic, you can take out 1 of them. If we start with quartic, you can take out 2 of them using the calculator. If we start at the 5th power, you can take out 3 of them using the calculator. But you have to get it down to quadratic. So once you've got it down to quadratic, we're going to either factor or use complete the square or quadratic formula to find the remaining solutions. So I'm going to write this as a quadratic now. X squared minus x plus 20. My first preferred method would be, is it factorable? Because that's faster. So I get x equals 5 and I get x equals 4. This says we have to find all the solutions. So I found all the solutions. I have x equals, what was the first one? -1 and then 4 and then 5. And then for extra bonus, it doesn't say to do it here. We are going to factor it because that's what we were doing with the other ones. So the original question factored would be like x plus 1. And then here's the other 2 factors. X minus 5, x minus 4. So you see I'm like combining things we've already done now. The only new thing on this notes was the multiplicity. Okay? So all the rest of these are repeats of what I just went over. My guess is this one probably has some multiplicity on it. We have like an extra minute. Let's graph this one on our calculator because I think it might have multiplicity. So I want to show you that. Yes. Maybe that's what this one is. I was trying to remember why it's a separate example. Maybe it doesn't have multiplicity. I wonder if this one doesn't have imaginary answers. I wonder if it has irrational answers that you have to use quadratic formula. For. Let me use that one thing that I told you about when you go second calc and you choose 0 and you do like left bound, right bound. I'm going to see if I'm going to actually try to look at the second one. To me, the second one looks like it is -1/2. To To me, the second one looks like negative a half. So I'm going to see, oh, I guess I could just type it in. Never mind. I'm going to do second trace value and see if it's negative a half. Negative 0.5. It is. That one kind of looked like negative a half. Okay. I'm also going to see if maybe the one next to it is positive half. Nope, it's not. So maybe, maybe it's this one. Maybe this one's negative 1.5. This one might be negative 1.5. Nope. Nope. How about, maybe I should just find, maybe I just find one. That was what I was going to do the first time instead of just guessing. Let's see if this one is one. Let's go. Not if it's a horrible decimal. So I'll just do, what was I going to do in the first place? 0. Let's see, negative 2, negative 1, and I'll try negative 1.5 even though I know that's not the answer. So that one doesn't look that nice. I just don't remember what this one is. How about between 1, I'm sorry, I'm just trying to find it now. Whoops. How about 1 and 4?
If you do like I can do 0 and 10 and then guess like 3 will be okay. It doesn't matter.
Right. Well, only if there's only 1 in between.
Oh, okay.
That's why I'm trying to do a small window, so there's only 1 in between.
Yeah.
Okay, I found it. It's 0.6. I think somebody guessed that even. So I got that x equals negative 1/2, and I got x equals negative, what is 0.6 as a fraction?
3/5.
Yeah, it is 3/5. Okay, what I need to show you is how to change this into a factor. No, it's not negative. And then there's probably going to be some questions on your worksheet that you won't be able to finish all the way. Most of your worksheet you'll be able to do, but this one, because it's got fractions, I feel like this will need to go over again. So just heads up. We need to change these into a factor. So to do that, what's the first thing that we were doing before is making it equal to 0, but this one has an extra step. Remember we changed it into a factor? This one has an extra step when I change this into a factor. What? No, this is a solution.
Yeah, okay.
A factor is in the parenthesis with like x plus something or x minus
Isn't
something.
it like a fraction?
It's not. That's why I got to go over this with you real fast. So in order, it's not going to be x plus 1/2. It's not going to be that. So in order to change this into the factor, you first have to multiply both sides by 2. Because when we had this kind before, we had to divide both sides by 2. So you have to first multiply both sides by 2, and I get 2x equals negative 1. And then I have to add 1 to both sides. 2x plus 1 equals 0. This is the factor. So I'll do that again with x equals 3/5. Nope. What should I do first? Multiply both sides by 5. Well, we're going to get it equal to 0, but first you have to multiply by 5. So you get 5x equals 3. And then subtract the 3. So 5x minus 3 would be the factor. So this, I didn't have time to finish this one. We'll have to pick it up here. But I am going to give you a worksheet because you can do most of the worksheet.
I don't understand. I'm allowed to do like 30 minutes.
It's not due till Monday.
Exactly what I'm allowed to do.
Oh yeah, you can definitely watch the video.
Pardon the interruption. I do have a couple afternoon announcements. Just a reminder, students that are driving, please be careful in the parking lot. Do not try to bypass the line of cars by going over the other side of the road into oncoming traffic. You need practice patience. Also, reminder, tomorrow morning, students should please report to second period class before going to testing. H-Fell tomorrow will also be second period. That does conclude the afternoon announcements. Have a great afternoon. Be careful driving. And as always, go Firebirds.
Oh, I was saying that.
Sorry. It's okay. It's the homework. I got it.
So I might just post the ones that I think you should be able to do. So if you get to the ones that I don't have posted, then you can just wait for those.